Hello, my name is Puji Rosita. I'm from Bandung Institute of Technology. I would like to present my study about estimation of probable maximum precipitation and probable maximum flood using GSSHA model, with the case study area is in the Upper Citarum watershed. As it is already widely known that PMF commonly used as the reference to ensure the safetiness of hydraulic buildings such as reservoir. However, in the other side, it also can be used as the reference for flood disaster management. The PMF value will be obtained from PMP because it's defined the theoretical maximum precipitation that may occur in one centered area and one certain given duration. The research conducted by Liu in 2017 showing that spatiotemporal distribution of PMP with the worst incidence of PMP done in every small parts of the watershed is very important to know in calculating the PMF value. However, the research towards this subject is still very rare. The purpose of this research is to estimate the PMP value using the rainfall data from satellite observation and calculate it based on the spatial distribution of rainfall, which the result will be combined with the hydrological models to produce the procedure for calculating PMF value in the Upper Citarum watershed. The data will be shown as below. Firstly, bias correction will be performed in order to validate the GSMAP data with the observation data, and in the study, the result is the bias correction is able to change the distribution of the GSMAP data closer to the observation data. And the second one, Hertzfeld statistical method will be applied for scenario A and scenario B, whereas in the scenario A, the PMP will be obtained in every grid of the GSMAP satellite data, while in the scenario B, the PMP will be calculated based on the mean area rainfall data. And the third one, after that, the PMP from both scenarios will be used to obtain the PMF using the hydrologic model. By employing both of PMP value from scenario A and from scenario B to the hydrologic model, it's found that averagely scenario A yields the peak discharge 13.12% larger than B. Both PMF value from scenario A and B with duration less than or equal to 24 hours consistently increasing. However, the 72 and 120-hour duration showing the supersaturated state, it indicated by a stagnant straight line on the hydrograph. The responses of watershed presented by PMF peak discharge is notably affected by the PMP value. Checking at the ratio between the peak discharge PMF and PMP, like showing in the figure 2, noted that there is a similar or equivalent pattern for both scenarios. This condition check with the comparison of the PMP intensity as shown in figure 3, and both of these scenarios has the same intensity when it reach equal or greater than 72-hour duration. It is resulting there is a contrary intensity value between observation data and GSMAP data, particularly for PMP duration 1 to 24 hours, but it's exceptionally happen for duration greater than 72 hours. PMP intensity for scenario A has a trend that the longer PMP duration happen, then the intensity is decreasing, but the PMP intensity for scenario B is likely constant from 9 to 10 mm per hour. So, in conclusion, the result presented that the spatial distribution of rainfall in the Upper Citarum watershed will affect the calculated discharge. PMF in 72 and 120 hours have quite similar output discharge for both scenarios. It indicated that both scenarios can be employed to calculate the PMF value with PMP higher than 72-hour duration in the study area. Nevertheless, for the PMP duration less than 72 hours, there is a relatively differences. In general, the peak discharge for scenario A is 13.12% larger than scenario B. So that is all my presentation. Thank you very much for your kind attention.